the Bitcoin paper. No one completed.
Uh, I read through the papers.
Like, was the later part understandable? Do you understand the complete?
Yes, sir. Yeah.
Uh, let's let's just quickly go through this code. Then we'll learn about what are different consensus mechanism, also like apart from proof of work. So, like the first file is that like you guys are comfortable with Python, like, or there's something that who is not at all uh, know about anything here, like in the syntax and uh, okay. I'll assume that every one of you know. Just give me a second. Yeah. So, we'll just look at the fundamental units that we discussed, like what we also saw in the Bitcoin paper. First thing is transaction. So, what a transaction would look like. It has only like three fields, uh, which is sender, recipient address, and amount. So, this is in simple. Uh, Sender and receiver wallet address and amount which is transferred. We are only considered like one kind of transaction as of now, which is sending money between two wallets. So, what is a wallet? We have created a pair of a public key and a private key. Uh, so, using a library called cryptography, we can like get a asymmetric pair created based on some parameters. So, we have created one private key and one public key, and wallet has a function called sign transaction. So any transaction that needs to be let go. So if I'm initiating a transaction which is from my sender address, which is mine, and recipient to someone else, so I need to sign that transaction. So that is the transaction here. Self, that should be signed by my wallet. So I'll just sign it using my private key transaction, and it's a salt hash of the transaction, and return that signed transaction. These are like wallet has only one function, which is right now to sign any given transaction. Don't If you don't understand like what everything uh, here is, just get the concept, and you can explore more of it. Uh, it's just pretty like simple as well. If you like read, some of the terms would be new to you, but we have checked earlier like what is and SHA-256 hashes, uh, and what should be the length. Salt is like just to add an extra element to the transaction, and we hash everything to a hash to message and return that signed transaction. So that is wallet and your transaction. Then we have a block. So what block is? As we have written the paper, block would can get the current timestamp of when it is going there. It will have a list of transactions, hash, previous hash of the block, like hash of the previous block, one nonce, and uh, a function which to calculate the entire hash. So the entire hash is calculated by like just adding all of them as a string and doing a SHA-256. This is a very simpler version right now, so it does not include any more complexity. But otherwise, there are more things which goes into a real network. Uh, Mine block functions uh, is will just gonna change the difficulty. Like for a given difficulty, we'll just incrementally increase the nonce, uh, starting from one, and we'll go on increasing until we get the hash which has initial difficulty is like four. If the difficulty is four, it should have initials 4 zeros. So until we don't get that, we're gonna keep increasing the nonce. And as this is a bit might take some time, uh, so that's a mining process, mining block function right now. Any confusion in this three section? How the wallet is defined, what's a transaction, and the block class.
Sir, what is for main block is used for, sir?
So mine block is used for calculate the proof of work, right? So any block just needs to be added to the blockchain. You have to submit a proof of work, right? That's what we read in the paper as well, right? Uh,
Okay.
so to get that proof of work, this is the work which is getting done right now to calculate a hash. So consider this as a math puzzle. So the simpler puzzle right now is will incrementally going to increase the nonce linearly until we get that uh, number of zeros, defined number of zeros in the hash. So this process is mining.
Thank you, sir.
Uh, so
So, uh, so
yes,
just a general note.
yeah,
What we're trying to do here is just to simulate Bitcoin, or
okay, yeah.
does it have any significance?
Just to simulate like what we read in the paper, just a simpler version to simulate uh, your own
And the mining is basically brute force that we are doing.
right now. Yes, in like more complicated systems, right? There are more algorithms that people would apply to optimize it. Uh, but yeah, it's basically brute force. That's why it takes a lot of computing power and GPUs because then only it's like multi-threaded and it just goes on trying uh, to find that nonce. It's basically brute force, nothing else. So that's why it's not done on CPU, because CPU is your single-threaded function and it will take you ages. That's why GPUs are used in the mining process to like make that process a little faster. Okay, so our blockchain class. So what what we have as a chain is an array right now. So each in the array, what we have is a blocks. So we have created first block, and then later instances of block class would be added to this chain. We have set difficulty to the 4, which means for any mining, the hash that would be accepted should have leading 4 zeros. Uh, pending transactions. So at any time, right, which are the pending transactions uh, before the block is mined. So block when the block is mined, it takes and a new block is added. It takes some transaction so that it will take from here. And a network is to like connect between different nodes. So let's go to the network class. So network class has uh, the self.nodes array. So it just keeps on track of what are the current nodes available. So if a new node is created, it will just add it to this nodes list. So that's what the register node process does here. It just adds the node to the append. This is like a linear network right now, but in a actual network, it's more of a graph network. And but this is just to like give you a bit of understanding. So we learned that, right? Whenever a new block or a is added or any transaction, it has to be broadcast to all the nodes. Uh, so what we're doing is for each node, we are saying that there is a new block which is there. Same for any transaction. To broadcast a transaction, we are just searching through this list and making each one of them like throwing, okay, this is a new block or a transaction. So that's what we are at the network instance to the blockchain. So the functions which are there in the blockchain are one is create genesis block. So that we have already called in our constructor. So because that only needs to be called once, you can also make this private for that sake. So mine block process, uh, what here will happen in, it will take the transactions. If are there any pending transaction, then only a new block needs to be added to the block, right? A blockchain. So if there are any pending transaction, it will create a new block, and on that block, it will call the mine block function. We already saw what a mine block function would do, and then once that is done, we'll delete any transactions from pending. So right now we have assumed that whenever a block is getting created, it will take all the pending transactions, but that's not happening in real life. Uh, but if there is no transactions, we'll just return. Uh, to add a new block to the blockchain, uh, we'll take a new block, find out the hash of the previous block to it, and then set it there, and then add that block to the chain, and then let broadcast to all blocks. So what are the VS extensions required to run blockchain in VS Code? Uh, Depending on which kind of suit you're using. So there are truffle suit, there is hard hat suit. So we'll see that as well in upcoming classes. We'll help you set up. So there is, if you go, there would be Solidity extension. You can, one thing is that you can install. Whenever, yes, Manoj, I'll share. So whenever there is a new block, this is the repeated function. So whenever there is a new block come, it will be only added to the blockchain if uh, that is a valid block, or if the consensus has happened on that block that it needs, it's the transactions are valid, and if the like hash which is currently in the blockchain in the main chain uh, is equal. So that's what we are just checking here right now. If the previous hash of that chain is equal, otherwise we'll reject that block. To create a transaction, uh, we'll just create a new transaction instance and it added to the pending transaction list, because it won't be completed until it is added to the block, and then broadcast to network as well that there are new transactions. Um, so like this would suffice all the elements that we would need to simulate. Then what I've done here is created like three different wallets uh, and three different nodes. So I have created three nodes. So as we have known, each node has a entire list of blockchain. Then we have registered those nodes within each other network. So every node is aware that, okay, this node exists. Then to like simulate some transaction, what I've done is created a few transactions between different wallets. So I've added wallet one public key, wallet two. So this is a transaction between wallet one to wallet two of 15 uh, currency. Same from node two and node three. I have like added some transactions to each of them. Now I've simultaneously called uh, my like each of the node which has received like which will try to mine will broadcast their nodes block if they have mined it. So whoever uh, mines first, that block would be accepted. Yeah, and then just print of what's the blockchain current state is on each node. So if you go and run this, something changed. Of course. Okay, this should come from by checking which node has broadcasted the transaction, and then getting the length of that particular node's chain. So I think I'll update this logic and then share the GitHub with you. I think that was the some simulation. Anything which like is which you couldn't relate, at least not relate to what is happening. Main pi you can ignore when I share, or I'll delete only. It was a earlier previous simulation that I was doing. The main simulation is simulate.py. Anything that like was way above height, like you can only relate that we've been talking in the last 3 classes. You're not able to relate only ki kya ho raha hai. Cool. So I'll share the GitHub with you. Then you guys, what I'll do is I'll reply to the email of this meeting itself. So I think you'll all get that email. So what next we have to do is understand what different consensus mechanism is. We already talked a bit about proof of work consensus mechanism, which states that whoever like get the block hash first would be like valid after validation. But why is like this consensus even needed? So like because we need something to like agree on. Otherwise, every node would just create its own blockchain, and we don't have a like commonly agreed uh, chain, which is the main chain. So that's why every blockchain has a consensus mechanism to validate, approve transactions, or add block. So we have already checked proof of work, which is based on solving the math puzzle. We have majorly 2 or 3 more which are widely used. One is proof of stake, and in the private blockchain, you would see uh, proof of authority. I'll just give you a visual understanding of what we are talking. Let me check if I'm sharing my audio.
Consensus algorithm, whose job is to ensure that transactions added to the blockchain are legitimate and that the network remains secure. In this video, we will discuss all the major blockchain consensus algorithms that are used across the globe, their characteristics, and how they work. So let's get started. Starting with number 1, proof of work or POW. Now, proof of work is the original blockchain consensus algorithm created by Satoshi Nakamoto for the Bitcoin blockchain. It works by requiring network participants to solve a complex mathematical problem which takes a significant amount of computational power. The first participant to solve the problem gets to add the next block of transactions to the blockchain and is rewarded with a predetermined amount of cryptocurrency. This algorithm requires a large number of computational power and energy consumption, which eventually makes it relatively slow and expensive to operate on. Next, number 2, proof of stake or POS. Now, proof of stake is a consensus algorithm that aims to address the energy consumption and computation power problems associated with proof of work. That's why in proof of stake, instead of solving complex mathematical problems, network participants are required to stake a certain amount of cryptocurrency in the network. And then
So like why like energy consumption like became a problem. I think around when the Bitcoin network started growing, up to like 2018, 2019, like there were a lot of mining grids set up, and the the total number amount of energy consumed for like Bitcoin mining and Ethereum mining was like way more, like it could like I think power the entire nation, like a small nation for a year or so, and that's what we've been using like on a very regular basis. So that's why so the proof of stake as well came into the picture. Uh, Ethereum was earlier on proof of work, similar to like how the Bitcoin system would have worked, but now I've shifted to a POS
On the
consensus.
basis of this, the network then randomly selects a participant to validate the next block of transactions based on their staked amount. And accordingly, this participant is rewarded with a transaction fee for their work. And this is exactly what makes proof of stake a faster and more energy efficient consensus protocol than proof of work. Further, proof of stake can be divided into two parts: delegated proof of stake and leased proof of stake.
So what is a staked amount? What happens is, so say you have 10 Ethereum and you want to become a validator or a mining node. So you would stake that amount. So staking means it gets locked for a certain amount of time. So until you want to be, it's called buying in chips. Consider them as buying in chip to be part of the group. So uh, you make your money locked and then get some voting rights. Uh, then you would ask like if what so in this case the richest person or who has the most Ethereum will always win. No, it's not like that. So it's basically like a random lottery system. Uh, so having more money staked means increasing your probability chance, but it's not guaranteed as well. So if staking is a lottery ticket, so if say one staking one Ethereum equals one lottery ticket, so staking more means you buy more lottery tickets, but it still does not guarantee that you will gonna always get the chance to like add a new block.
Let's understand each of them one by one, starting with delegated proof of stake or DPoS. Well, it is a variant of proof of stake consensus algorithm used in some blockchain networks. In this, token holders vote for a group of delegates to validate transactions and create new blocks on their behalf. These delegates are typically chosen based on their level of activity and contribution to the network. Further, delegated proof of stake or DPoS can achieve faster transaction times and higher throughput compared to other consensus algorithms like proof of work due to the delegation of validation process to smaller group of trusted nodes and is used in blockchain networks like EOS and Tron. Next, number 4, leased proof of stake or LPOS. Now, leased proof of stake is a small modification of delegated proof of stake consensus algorithm that allows users to lease their currency to a chosen delegate in exchange for rewards. The delegate then uses these leased coins to increase their voting power and become a more prominent validator in the network. This leasing system helps to promote decentralization by allowing smaller tokens to participate in the validation process and receive rewards even if they don't have the resources to become a delegate themselves. However, leased proof of stake can still be susceptible to centralization if a small group of delegates control a significant amount of leased coins.
Uh, so in the delegate, what happens is some nodes would be chosen. Okay, now you have a authority to like compete for mining the blocks. So it's basically based on it can be on anything based on the number of coins you have, or maybe you are very active in the community of that particular Tron, like particular chain, or you have contributed to the code for that chain or any other thing. So if once you become a validator, then you are like eligible to like run for adding a block. In least proof of stake, what happens is, so now as we're discussing, right, buying a lottery ticket. So consider when there is a large amount, like large number of people buying lottery. So the probability of you getting chosen also decreases. So if we had only 1,000 lottery tickets, uh, if you buy one, your winning probability is 1/1,000. But if there are million lottery tickets, your probability shrinks to 1/1,000,000. Uh, so what happens is to increase like getting some rewards on your money, what people do is they put a money in a stake or a pool. So 5 friends say we're gonna pool our money and buy like more tickets on the same name, same node, so that that node's power became a little much more. So that's how the pooling works. So there's a lot of companies that like help you set up or be a pool, part of a pool. So I think that's
Next, number 5, proof of authority or POA. Now, this is a consensus algorithm which is primarily used in private or consortium blockchains, and in a nutshell, the validators in this network are known and trusted individuals who are authorized to validate transactions on the network. And if seen from a performance perspective, this algorithm is faster and more efficient than proof of work or proof of stake or any of its variant. But in doing so, it sacrifices on decentralization, which in a way is one of the crucial fundamentals of blockchain technology. Further, if you want to understand the difference between proof of stake versus proof of work versus proof of authority on a more detailed level, I will recommend you to watch or be to commit a fraud. We all must have heard of situations where below. Next, number 6, Byzantine fault tolerance or BFT. Now, we all must have heard of situations where some malicious actors have hijacked the control of the network fundamentally to commit a fraud. Byzantine fault tolerance or BFT is a consensus algorithm that is fundamentally designed to tolerate such malicious factors in a network by ensuring that all nodes on the network agree on the current state of blockchain. Here, the primary goal of BFT is to achieve consensus even if some nodes are malicious or fail to function properly. Think of it like a group of people trying to make a decision together. In a normal situation, everyone could just vote and the decision with the most votes would win. But in a BFT system, some of the people might be lying or giving fake information, so it's not simple as just counting votes. To solve this problem, BFT uses a system of checks and balances that require multiple nodes to agree on a decision before it's finalized. It's like having a group of judges who all have to agree on a verdict before it becomes official. Thus, this consensus mechanism ensures that all nodes on the network are working together to maintain the integrity of the blockchain. Further, BFT is particularly useful in permission blockchain networks where nodes are known and trusted. By using BFT, these networks can achieve faster transaction processing times and higher throughput compared to other consensus mechanisms. If you want to learn more in depth about BFTs and its working, I would recommend you to watch this video on my channel. Link for the same is given in the description below. An example for BFT includes Hyperledger Fabric, and further, just like proof of stake, BFT can also be divided into two derivatives, practical Byzantine fault tolerance and delegated Byzantine fault tolerance. Let's discuss each of them one by one. Number 7, practical.
this is more the last two which we saw, proof of authority and BFT, are mainly used in private blockchains. They're like some nodes have more power than the other nodes and are the authoritative nodes, which will decide mainly what happens. So that's why it's not fully decentralized and used in private networks.
Byzantine fault tolerance or PBFT. Now, PBFT is a variant of BFT and ensures that all nodes in the network have a copy of blockchain and can validate new transactions and blocks before they are added to the blockchain. And accordingly, a consensus is reached if 2/3 of the validators in the network agree on the transaction. If seen from a performance perspective, PBFT is faster and more efficient than BFT. But in a sense, it requires a certain level of trust among validators. One of the main advantages of PBFT is that it provides a strong Byzantine fault tolerance, meaning it can tolerate a large number of faulty or malicious nodes in the network. Additionally, a big drawback of PBFT is that it's not well suited for networks with a large number of nodes, as the number of messages required to reach consensus increases exponentially as the number of nodes in the network grows. Next, number 8, delegated Byzantine fault tolerance or DBFT. It again is a variant of BFT, and here nodes are assigned to groups with each group having a designated leader, which is also known as a delegate. These leaders or delegates are responsible for proposing new blocks to be added to the blockchain, and accordingly, other nodes in the group then validate the proposed block before it is added to the blockchain. This process reduces the number of nodes that need to agree on a decision, thereby making the consensus process faster and more efficient. Further, DBFT is generally considered to be faster and more efficient than PBFT due to its delegated network model. It can be particularly useful in a public blockchain network where fast transaction processing times and high throughput are important, while still maintaining a high level of security and reliability. Next, number 9, direct acyclic graphs or DAG. Now, direct acyclic graphs or DAG is a data structure used in blockchain technology that differs from traditional blockchains, as unlike a linear chain of blocks, a DAG is a collection of nodes or vertices that are connected to each other in a non-linear way. Each node in a DAG represents a transaction and contains a reference to previous transactions, forming a directed acyclic graph. Further, the beauty of DAG is that here, transactions can be processed in parallel, allowing for faster transaction processing times and higher throughput compared to traditional blockchains. In such a network, there is no need for miners or validators to compete to add new blocks to the chain. Instead, nodes validate transactions and add them to the DAG, and other nodes verify the transactions before they are confirmed. This process is known as consensus by validation. DAG-based blockchain networks such as IOTA and Nano are often used in applications where fast transaction processing times and higher scalability is essential, such as Internet of Things or IoT, and machine-to-machine transactions or M2M transactions. Next, number 10, proof of capacity or POC. Now, proof of capacity is a consensus algorithm used in blockchain networks such as Burstcoin. In POC, participants are required to show that they have allocated a certain amount of disk space to the blockchain network. This allocated space is used to store and validate transactions. and accordingly the participant is rewarded with some cryptocurrency amount that is proportional to the amount of disk space they have allocated. Next, number 11, proof of burn or POB. Well, it is a consensus algorithm that requires participants to burn a certain amount of cryptocurrency in exchange for the right to validate transactions on the network. In order to burn the crypto, it is sent to an unspendable address, effectively removing it from the circulation. And once this is recorded, the participant is then rewarded with proportional amount of new cryptocurrency created by the network. Next, number 12, proof of identity or POI. Now, in this consensus algorithm, network participants are required to prove their identity through various means such as government-issued identification, biometric data, or social media accounts. And only once their identity is verified, participants are allowed to validate transactions on the network and accordingly are rewarded with the cryptocurrency. Next, number 13, proof of activity. Now, proof of activity is a hybrid consensus mechanism used in blockchain technology that combines proof of work and proof of stake to help ensure security and reliability of the network. In this, miners first perform proof of work to create a new block, and then validators confirm the block using proof of stake. This process ensures that the network is secure and efficient, as proof of work prevents double spending and proof of stake encourages participation and prevents centralization. And because of this, proof of activity helps in improving the speed and scalability of blockchain networks while still maintaining a high level of security and reliability. Next, number 14, proof of elapsed time or POET. Now, this is a consensus algorithm primarily designed for permissioned blockchains and is developed by Intel. In POET, nodes compete to generate a random wait time, and the nodes that complete the wait time first is chosen to create the next block. Here, to ensure that nodes don't cheat by generating shorter wait times, POET uses special hardware called Trusted Execution Environments or TEEs that create a random wait time and protect it from manipulation. Fundamentally, POET is a more efficient and environment-friendly consensus algorithm than traditional proof of work because it doesn't require nodes to perform complex mathematical calculation, and instead, POET relies on the random wait time generated by the TEEs. Next, number 15, proof of importance. Now, this consensus algorithm.
So what happened in this is, you have a dedicated hardware chip that will give you random wait time, and whoever has the less wait time would mine block at that particular time.
In blockchain determines which node gets to validate transactions and create new blocks based on their level of activity and contribution to the network. This activity is measured by users' importance score, which is generally calculated based on the number of transactions they have made and the amount of currency they hold. Nodes with high importance score are more likely to be chosen to validate transactions and create new blocks. This incentivizes users to actively participate in the network and maintain a stake in the currency, which helps to ensure the security and stability of the network. However, it can also make the network more centralized, as users with a large amount of currency may have more influence over the network than smaller users. Lastly, in conclusion, I'd like to say that choosing the right consensus algorithm is crucial for the success of the project, and you should consider factors like security, decentralization, efficiency, scalability, and fairness while assessing your choice.
So the most used are only 3, 4. There are many blockchains as well that use many different ones. That's why I just let you, if somewhere you heard the term, you at least know, okay, this is a consensus mechanism and that's how it works. Any doubt in any of it. I know somewhat you might have not remembered maybe all of it, but that's okay. You should only be remembering top 3, which is proof of stake, proof of work, delegated proof of stake, and proof of authority, which is used in private blockchains. Any doubt in this till now?
Sir.
Any discussion?
Hello, sir.
Yes.
So if someone mines one block, let's say,
Yes.
but how does he get awarded? We rewarded from which, from whom? The points.
Why would you mine a block, right? Why would you spend your computing power or your money? Why would you stake?
No, I'm saying that
How it is awarded. Okay.
means from whom the money?
So it is consider it's a mathematical function that will generate new coins in circulation. So what happens is you have each blockchain would have say different number of money that can be issued. It's not that there would be infinite money, right? Otherwise, after a point, the value of that currency would go low, right? So say for in Bitcoin, there are only 21 million Bitcoin that can be come to the circulation. So in simple terms, consider when you mine a block, RBI would print new money and give it to you.
Okay.
So that's the money which was not in the circulation before, but just added now as you have mined the block as a reward. So over the time, the number of coins in the circulation increases. So that's why the miners who get the money then go and like sell on exchange or somewhere. But that's not some money that they have bought from some account. It is a new money which has been transferred to their wallet.
Okay.
Um, so if you want to read more, you can like also go to Ethereum.org/consensus mechanism. You will read more about each of it. What are some attacks that can happen on that particular consensus mechanism? Um, and there would be some more readings if you want to go deeper in any of that what we discussed, like the Bison fault or any other algorithm, and what to like know which blockchain uses more, so you can like find out. You can take out your like top blockchains and then read about okay which consensus it uses. So like you will try to relate more about okay why which is using what, why I have read this, and like so on.
And sir, how to participate in a blockchain?
To become a node, right?
Uh,
Okay. So if I talk about Bitcoin, so there is an operating system or the like node, some code that you have to run on your network or your computer, which will run as an application. There are special like Linux systems as well, which just run that particular thing, connects you to that network. We like saw that each node needs to communicate to each other, right? So how there is we are on internet. So internet is what also it's a collection of distribution in the network. So similarly, uh, once you install that system, like software, you would be connected to that particular network, and uh, it requires certain amount of like disk space uh, and other thing, which is like computing power and like disk space, because all the blockchain data would be like would come to your system as well. So at particular time, each node would have a copy of its the entire blockchain transactions, right? So if you met all these certain criteria, you can become a node. There are also special hardware called mining rigs that people like use to just you can go and buy one. Uh, so like if you see, these are like a special hardware systems that people use to just run this computer chip here only knows the software to run the blockchain node. So these are like a small gigs. Uh, the more GPU stack, more powerful your system would or probability increases. So there was a time, I think, due to Bitcoin, like the mining process and now AI, NVIDIA has benefited the most because here as well, the graphic cards. Uh, I think there was a time in 2018, 2019. I think that there was a shortage of graphic cards because there was so much demand due to the mining rigs. and like prices were so inflated that the GTX graphic cards that used to like cost about 25, 30 got shoot up to like 45, 50, 60 even. So yeah, so that's how you can participate to become a node. And now for Ethereum, now Ethereum you don't need uh, all this mining rigs because Ethereum has moved to proof of work consensus, proof of stake consensus. So you need to have certain amount of Ethereum and stake it to the network. So for that as well, there is a piece of software that you need to run on your system and connect your wallet, which has Ethereum money, uh, Ethereum currency, and then it's staked on the blockchain network by a protocol.
Yeah, obviously.
This was another paper I was like going through, but yeah, it's not much of information here. It's too detailed about different uh, consensus mechanism. So that's why if you want to learn more, uh, let's go here. I'll share this in chats. Uh, so what I'll ask you guys to do is go read proof of stake a little more, because now, as we discussed, how a Bitcoin blockchain works, we're going to discuss in the next class how Ethereum chain works. And because Ethereum is the most large, uh, the second largest network after Bitcoin in mechanism, but all the coding that we will be going to do, all the smart contracts that we're going to write, we would be doing it on Ethereum network or uh, chain based on Ethereum network, like a layer two solution, like a Polygon. We'll also learn about what's layer one chain, what's a layer two chain. Uh, with Ethereum, Polygon is a layer two chain. So, so all these chains uses proof of stake mechanism. You can read about them. Uh, just read, get an understanding of proof of stake works. Now I think you have uh, more of understanding how mining works, but proof of stake is not mining. Uh, you can also check this block by Vitalik Buterin. So Vitalik Buterin is the guy who invented Ethereum. So as we know, in block Bitcoin, we know pseudonym by a guy called Satoshi Nakamoto, which we don't know who is. But Ethereum is done by Vitalik. So this guy invented the Ethereum network when he was 19 years old. And in 2012, or yeah, around 2012, he invented write the paper uh, for Ethereum. And then it it changed the entire system of how the blockchain and works. Because of this Ethereum, now we have like multiple use cases that can be like created around blockchain technology. Like we wanted to lower out where instead of payments where we can use it. So for supply chain, for like labor law, for tracking, tracing, for like creating more DeFi networks, DeFi protocols, investment, and other things. Everything which is depending on a smart contract, uh, which was possible after on Ethereum earlier. Now also Bitcoin network has smart contracts, but which is not widely used. Most widely used are on the Ethereum network. So we'll start the Ethereum in the next class. I'll send you an email with some links to go through and also the GitHub link for that code we saw today. So any doubt, or otherwise we'll wrap up today's class a little early. Not early, but usually we go 10-15 minutes beyond, but today we'll wrap it up on time.
Sir,
Yes.
like we know that blockchain as a means it is very much useful, but why we aren't adapting it to it? Like why the Indian government in some of the foreign countries like it's used, right? It's legal.
So in India as well, right? There, I'll tell you what the problem of Indian government is. Uh, the thing is, large network, like large population of India does not know, is not that tech literate to understand the system. So they put their money on scams and then lose money. The other thing is Indian government does not want a lot of money going out of the country. So they don't want too much money getting converted from Indian rupees to any cryptocurrency. That's why they oppose. It's not illegal uh, to have the cryptocurrency in India. That's a misconception about the news. They have banned certain exchanges, but to hold cryptocurrency, it's not illegal. If you convert, yes, there is a tax, which is very hefty. Until you don't convert it back to INR, also you don't need to pay tax. Yes, some governments are very prone to blockchain, like Dubai, Singapore, Hong Kong. These governments are much more uh, helpful in forming like regulation, informing, like supporting. But yeah, we're also seeing some significant traction in Indian government, uh, like Telangana uh, is having a good response. Like Telangana government is having a good response in blockchain. They like also had they selected some startups to work with, like they selected I think 10, 12 startups to like run a pilot project with them. Some other governments, I think Karnataka is trying to like get real estate registry on blockchain. In Telangana also did this for one of the new cities in Hyderabad. So yeah, I think there is, but yes, the most of the Indian government focus a lot on uh, private networks or at least control. The thing is, they don't want to lose their control. So that's the only problem. But yeah, we should be seeing much more activity in the coming years. Uh, why would be learning like blockchain helps you up? Because it opens you to a global network of opportunities.
Only one
So
is like Indian based, right?
it was started in India, but now their headquarters is shifted to Singapore. So now it's no more like it's the founders are still Indian, they live in India, but the company is still registered in Singapore. So a lot of companies that started in India has moved to Singapore and Dubai. And a lot of exchanges has moved to Cayman Islands. obviously to do start. So yeah, cool guys. Thank you everyone.
Excuse me, sir.
Yeah, man, I'll text you up.
Yes, sir.